Introduction of the Science History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Larry Wilson. The Science History of the Universe, Volume 1, edited by Francis Rolt-Wheeler. Astronomy. Introduction. In the present volume there have been covered in a comprehensive and popular manner the various departments of astronomy. Owing to its treatment in a definitely historical and descriptive manner, however, it may be possible to supplement the general review by a few brief statements of some of the results and problems that confront us in the actual work of the observational astronomy of today. There is frequently brought before the astronomer the fact that certain subjects that were apparently exhausted have proved through the more advanced methods of today, or perhaps by chance, to be veritable mines of discovery, richer by far than had been anticipated in all the previous investigations. A remarkable illustration of this fact is the splendid work of Professor Hale at the Solar Observatory of the Carnegie Institution at Mount Wilson, California. The Sun had almost been relegated to that limbo from which nothing new can ever come. With the exception of Hale's development of the spectroheliograph, which made possible the continuous photographic study of the surface of the Sun and of the solar prominences, but little advance had been made in solar research for a very long period of time. Even with the new instrument, the work seemed to be confined to the photography of the prominences and a few other features of the Sun that were already observable visually with the spectroscope. Before this, the Sun was somewhat of a curiosity, and but little new information was had concerning it. It only became really interesting when a total eclipse was imminent, at which time the corona could be seen and studied. The spectroheliograph was the first great step in the study of the Sun. Even though this made possible a continuous photographic record of the prominences and kindred features, it could not record the more attenuated and delicate corona. Indeed, we seem today as far as ever from any sight of this mysterious object without the aid of the friendly Moon, which for a few minutes at long intervals hides the Sun and gives us our only view of the corona. But the great work done by Professor Hale and his associates at Mount Wilson, which was foreshadowed by his work at Yerkes Observatory, in the discovery of the solar vortices and magnetic fields of sunspots, has revolutionized the study of that body and opened up new fields of investigation in this direction that are almost unlimited. Mr. Abbott of the Smithsonian Institution has also established a permanent station at Mount Wilson for the investigation of the solar constant and a general study of the heat of the Sun. The solar investigations, therefore, that are going on at Mount Wilson are among the most important that have ever been undertaken. They are not only of the highest interest, but may ultimately lead to important results bearing upon the commercial life of the world by revealing to us some possible means of forecasting conditions upon the Earth. Any vagaries in the Sun must have more or less direct influence on the conditions of the Earth, which owes its very throb of life to the mighty influence of the Sun. Much of the ordinary spectroscopic work may be said to be in its infancy because of the vast fields of research that are open to it. It is already laying the foundation for a very accurate determination of the distance of the visible binary stars where both stars can be observed with the spectroscope, an accuracy that can never be obtained by the ordinary methods of parallax work. Already this has given results of precision in the case of Alpha Centauri, whose distance has been determined by Professor Wright of the Lick Observatory from spectroscopic observations combined with the known orbit of the star. Time, however, is an element in this work, and after a sufficiently long interval a valuable harvest of knowledge of star distances will result. The spectroscopic material for such investigations is being specially obtained by Professor Frost and his associates at the Yerkes Observatory, as well as by others elsewhere, where spectrograms of the various visual binaries that are bright enough to give a measurable spectrum are being carefully and accurately accumulated. A possible improvement of the spectroscope, whereby a larger percentage of the light can be utilized, will make possible the extension of this class of work, for at least 90% of the available light cannot at present be utilized. If this can be done, the efficiency of the spectroscope will be vastly increased and a great number of objects at present beyond the reach of accurate spectroscopic study will be investigated and their nature and physical conditions become known. A step in this direction is the intended erection on Mount Wilson of a reflecting telescope 100 inches in diameter. The great light grasping power of this instrument will enable much fainter objects to be studied than can be observed with the present means. Only a few years ago our knowledge of comets seemed to be satisfactory. What we could see with the naked eye or with the telescope apparently readily agreed with certain theories that were formulated to explain them. The tails of various comets were sorted out and assigned to different classes. This one was a hydrocarbon tail, and that a hydrogen tail, etc. The spectroscope had shown that comets in general consisted of some form of hydrocarbon gas, such as cyanogen. Such gas or gases are evidently mixed up with the minutely divided matter which is disrupted and expelled from the comet's head and thrown out backward from the comet away from the Sun. This was shown later by the experiments of Lebedew, Nichols and Hull to be due to the pressure of the Sun's light upon the smaller particles of the comet, which drove them away into space with increasing velocity to form the tail. The simple phenomena thus seen by the eye were rather easy of explanation. Photography, however, has revealed such a mass of strange phenomena in these bodies that the theories which seemed so satisfactory before are now seriously questioned, and some of them appear to be entirely inadequate to explain some of the phenomena shown by the photographic plates. But little indication of many of the most extraordinary changes and peculiarities of comets' tails is seen by the eye. In part this is due to the fact that much of the light of a comet is of a nature that has but little effect on the human eye, though it is peculiarly strong in its action on the photographic plate. The first of these bodies to exhibit these peculiarities was Comet 4, 1893, Brooks. Some of the phenomena of its tail, as revealed by the photographs, appeared to defy the ordinary theories and seemed to show that an influence outside that of the direct action of the Sun upon the comet had manifested itself in the distortion and breaking of the tail. The scarcity of active comets in the succeeding years left this question in abeyance. Comet C, 1903, Borrelly, however, gave us much information as to the actual velocity of the outgoing particles of the tail, some of which receded from the comet at the rate of 29 miles a second. This object also quite clearly showed that a seat of force of great activity existed in the comet itself, which enabled it to shoot out streams of matter at large angles to the main direction of the tail, which were apparently not bent or affected by the pressure of the Sun's light. The phenomena of Comet 4, 1893, were repeated in Comet C, 1908, Morehouse. But a great amount of the new phenomena was also shown by the last body, which demands still greater changes in our ideas of comets and their tails. This object is so recent and its phenomena so startling that astronomers have not yet had time to thoroughly discuss the vast amount of material that exists for its study. Briefly, added to the already known rapid changes in the tail of a comet, this object exhibited the most extraordinary freaks. Tails were repeatedly formed and discarded to drift out bodily in space until they finally melted away. In several cases the tail was twisted or corkscrew shaped, as if it had gone out in a more or less spiral form. Areas of material connected with the tail would become visible at some distance from the head, where apparently no supply had reached it from the nucleus. Several times the matter of the tail was accelerated perpendicularly to its length. At one time the entire tail was thrown forward and violently curved perpendicularly to the radius vector in the general direction of the sweep of the tail through space. This peculiarity is opposed to the laws of gravitation. There is no known cause for this freak of the tail. Evidently we have here, and in many other of the phenomena of this body, some unknown influence at work in the planetary spaces. What this is one of the great problems for the future to solve. It has been suggested that many of the unaccountable phenomena of this comet are electrical and can be attributed to the same influence that produces our magnetic storms and auroras on Earth, and these are believed to be due to abnormal disturbances on the Sun. It is to be hoped that the present return of Halley's comet will add much to a solution of this problem. The study of the dark or apparently vacant regions of the sky, especially in the Milky Way, is of paramount importance. The photographic plate has shown that the dark regions, the so-called coal sacks, are generally connected with masses of nebulosity or gaseous matter. These are especially remarkable in the regions of the stars Theta Ophiuchi and Rho Ophiuchi. In the latter case we find a magnificent nebula in a rich region of the Milky Way, occupying a hole that is apparently devoid of stars. Some astronomers have attributed the general absence of stars here to absorbing matter, to an opacity and partial dying out of the nebula that cuts off the light of the stars which are beyond it. What these apparent vacant regions really are is therefore an unsolved problem at present. Some of them are evidently due to the thinning out and actual absence of stars in those parts of the sky. But the others, which are connected with nebulosities, seemingly must have some other explanation. One fact that appears to be brought out by the great nebula of Rho Ophiuchi is that the groundwork of the Milky Way in this region, and by inference elsewhere, may be made up of stars actually much smaller than the average of those seen in the general sky. If this were so, it would materially change our ideas of the Milky Way. This supposition comes from the fact that the great nebula is connected with some of the brighter stars in this region, while at the same time there is apparently evidence that it is connected with the faint stars that form the groundwork of the Milky Way here. If, however, the dark regions about and near the nebula are due to the absorption of light by an opacity of the nebula, the supposition as to the relative sizes would not hold, for the nebula in that case might be very much nearer to us than the Milky Way. It will be evident that an understanding of the nature of the dark regions of the Milky Way is of the utmost importance to a proper knowledge of our stellar universe. The great nebulous regions of the sky that photography has revealed to us are intimately connected with the Milky Way. They cover very large regions of the heavens and must be almost inconceivably great. In no case has it been possible to determine the exact dimensions of these wonderful objects, because we do not know their distances. It is possible, however, by assumptions that are justified by facts, to arrive at some idea of their minimum extent. If they are no further away than the nearest fixed stars, and from their evident connection with certain stars we know that they must be much further away, we can form some idea of their vastness. Our own Sun, if removed to the distance of the nearest fixed stars, would present an apparent diameter of about the 100th part of a second arc. Its known diameter is something like 1,000,000 miles, accurately 867,000 miles. Some of these nebulous regions are many degrees in diameter. The one connected with the Pleiades is 10 degrees in diameter. It is certainly connected with the cluster whose distance is much beyond the nearest fixed stars. From this it will be readily seen that this great nebulous region must be at least some 4,000,000 times greater in diameter than our Sun, or over 100,000 times greater than the entire diameter of our known solar system. These are figures that appear to be appallingly great, but they are only relatively so, and only shock us because the facts are new and we are not used to them. What is the ultimate function of these enormous masses of gaseous matter that we find lying in space? Are we sure that they are the primitive matter from which worlds and systems are finally to be evolved? These, very briefly, are a few of the problems that we encounter in astronomy as developed by the subtle means of research in use at the present time. E. E. Barnard. End of introduction.